Hey everyone, welcome in to Unit 6, Day 2 Notes. Today, our objective is that students will be able to isolate and solve equations with absolute value, and the key part to today is including special cases with an 80% accuracy or higher. Yesterday, we talked about in Day 1 solving absolute value equations, and today we're going to talk about specifically the new piece is including special cases. So let's go ahead and get started. First step is the same as yesterday. So we're going to isolate the absolute value. The second thing that we have written here is going to be the special case situation. So after we isolate the absolute value, we want to check. And if we are equal to a negative number, it is automatically no solution because an absolute value cannot come out to be a negative number because it's the distance from zero, and distance can't be negative. So if we isolate, and only after we isolate, if we see that the solution or the answer, not solution, but if the answer is negative, then it is a no solution. We stop the problem right there and write no solution. Other than that, we just continue as normal. If it is not a negative number, we just continue like yesterday. So we split into two equations. We drop the absolute value bars and we set equal to the positive, and we set the equation equal to a negative, and then we solve for x. Okay, so that being said, let's go ahead and try some examples and keep on the lookout for situations that involve special cases. So in number 1, the absolute value bar is isolated. So we're going to jot that down. We're going to say the absolute value, value is isolated and it equals a negative number, right? It equals negative 10. So in this case, we stop the problem right there. It is a no solution situation. Okay. All right, let's take a look at number 2. So as always, we want to isolate the absolute value bars, which means we need to get rid of this negative 3, which is next to, which means multiplication, so we must divide by negative 3. Those cancel out. We're left with the absolute value of x minus 3 equals negative 4. So after we divided by the negative 3, the absolute value is now completely isolated. There's nothing left on the left side of the equation other than the absolute value. And it equals a negative 4. So because it equals a negative number, we stop right there and we just write no solution. All right, let's take a look at number 3. So a little bit more for us to do. We see that it equals a negative number right away, but we cannot make that decision until the absolute value has been isolated. So we need to subtract 5 from both sides. We are left with negative 2 times the absolute value of 3x plus 3 equals negative 13 minus 5 is negative 18. Okay, well, you might be saying, we still have a negative number, but we still have not completely isolated the absolute value bars. We need to divide by negative 2. And this is where it's important to make sure that you are double checking, especially if you're not confident with your operations with integers, positive and negative numbers. So we are now left with 3x plus 3. Negative 18 divided by negative 2 is a positive 9. So you can see we started with a negative, but after isolating the absolute value bars, we see, we actually have a positive on the right side of the absolute value of the equation. So this is something we can continue to solve just like yesterday. So 3x plus 3 equals 9, right? We drop the absolute value bars. set equal to positive 9, and then we drop the absolute value bars and set equal to negative 9. Okay, let's go ahead and solve each of these. So we subtract 3. 3x equals 6. Divide by 3. X equals 2. Subtract 3 from both sides. We get 3x equals negative 12. Divide by 3. We get x equals negative 4. Okay, great. Go ahead. I'm going to pause, and you guys can try number 4. Check back in a few seconds. See you in a few. All right, welcome back. Let's go ahead and check our work. So this one turns out to be just a normal solving of an absolute value equation, just like we did yesterday. We go ahead and solve, and when we isolate the absolute value bars, we get positive 14. Then when we split, we make sure we split and make one of those equal to a negative 14. We solve, we get x equals 4 and x equals negative 3. All right, let's go ahead and flip over to the backside and take a look at a few more examples. So we have number 5, and the absolute value bars are not isolated. We still have that negative 5, and we have a plus 2 times the absolute value of 5x. So in order to start our process, we have to add 5 to both sides. And we're left with negative 8. Then we go ahead and divide by 2 on both sides. And we're left with the absolute value of 5x equals negative 4. So right there, it is equal to a negative number. So we stop and we just write no solution. We're going to wait and leave 6 for y'all to do. And we're going to take a look at number 7. Okay, so same process. Even though the absolute value is on the right side, we still want to isolate it just like we did before. So we're going to subtract 3 from both sides. And we get negative 12 equals negative 3 times 4 minus 2x. Then we're going to divide by negative 3 on both sides. And then that negative 12 turns into a positive 4. Okay, and now we need to go ahead and split. So we have 4 equals 4 minus 2x. And then we make 4 negative this time around. So it's negative 4 equals 4 minus 2x. And we go ahead and solve. So minus 4 on both sides. Divide by negative 2. And we're left with x equals 0. And then for the equation on the right, we get something a little bit different. We get positive 4. So x equals 0 and x equals positive 4. Those are our two solutions. Okay, let's go ahead and do one more together. We're going to take a look at number 9. And again, it starts off being equal to a negative, but that does not mean anything. We have to first isolate the absolute value before we make our decision. So we subtract 5 on both sides. We are left with negative 2/3 times the absolute value of x plus 8 equals negative 14. Now to get rid of a fraction, well, first we're going to multiply by the denominator. And we are left with negative 2. So that negative sticks with x plus 8 equals negative 42. Now we divide by -2. And when we divide a negative by a negative, it becomes a positive. So we have positive 21. So as you can see, it started as a negative, and as we go through the process of isolating our absolute value, it comes back to being a positive. So you can't make that call until the absolute value has been isolated. I cannot stress that enough. And then after we isolate and see that we do have possible solutions, again, we set equal to positive, and then we set equal to a negative. Subtract 8. We get x equals 13. Same deal over here. We subtract 8. But this time we're subtracting from a negative 21. And we get x equals negative 29. Okay. Pause the video here. Go ahead and try the 3 problems on your own. All right. See you in a few. All right. Welcome back. Let's go ahead and take a look at the answers. So for number 6, we go ahead and it starts off as a -4. And even though it's on the left side of the equation, we still go through the process as normal. So we have to get rid of that -6 by adding it to both sides. And it goes from a -4 to a +2. So yes, this is an equation that works. We can go ahead and split it and solve for the +2 and the -2. And we got x equals 7 and x equals 3. All right, taking a look at number 8. This one ends up being a no solution. And this one starts as a +4. And then after this process, because we have to divide by a negative, right? We have 21 divided by -3. It turns into a -7. The absolute value bars are isolated. It equals a negative. So it is no solution. And on to number 10. So in order to get rid of that denominator, we have to multiply by the denominator on both sides. And even though it starts off as a -9, goes to a -45, we have to divide by that -1 to the left of our absolute value, or attached to our absolute value. So we divide by a -1, that turns a -45 into a +45, which means, yes, this is something that we can solve and split because the absolute value is isolated and it equals a positive. So after we go through the process, x equals 19 and x equals -26. Okay, that is it for day 2 notes. Thank you all for stopping by. Make sure you reach out to your teacher if you have any questions. Have a great day. Peace out.